Okay, so here's another one now. Let's do this. So g looks like g of x is x squared. So we have to show this abomination equals this. Alright, come on, we'll just go left hand side, then right hand side, and hopefully it'll all come out in the wash for us. So g of x equals x squared. So the left hand side is g of u plus v plus g of u minus v. Okay, let's go with that. Now, g of u plus v, ladies and gentlemen, what would that be according to this function notation? See, you're replacing x with u plus v. So it would be u plus v all squared, wouldn't it? And the other one here would be u minus v all squared. You see? Now we're just going to multiply this out because there'll be some cancellation throughout the nation that happens when we simplify it. U squared plus 2uv plus v squared plus u squared minus 2uv plus v squared. That's the cancellation throughout the nation. And we're just going to get 2 times bracket u squared plus v squared. Now, okay, let's go with our right hand side now. That equals, that's pretty simple, isn't it? 2 times g of u, of course, is u squared, and g of v, of course, is v squared. So we get this. So it's pretty obvious now that the left-hand side equals the right-hand side, yeah? Piece of cake, guys, piece of cake. Now, here's the calculator wizardry. So we can say here that, or should I say Kazadry, So this is x squared is put into the calculator as f1 of x, and we do that. And then we say that we simply say that the left-hand side equals the right-hand side. There, have a look. Yeah, and we get a true. We get a true. So that means that everything's good, and the calculator agrees that that is a true statement, no matter what the values of u and v might be. Okay. Now, if you don't get a true statement, you might get something else, which means that's a bit dodgier. It means that the calculator is accepting it as some sort of a proposition, but it doesn't recognise it as being universally true. So if that happens, you might want to choose a value for u and a value for v, and basically work out the left-hand side and work out the right-hand side and see if they're equal. Okay, but the purest way of doing it when it's universally true is like this. Okay, yeah, pretty interesting, isn't it? Alright, another, question 10. We've got 3 likely looking customers here for us to deal with. It looks like f of x is e to the x plus e to the minus x, and g of x is e to the x minus e to the minus x. We have to prove those 3 things. Alright, we'll go with 1 now. F of x squared apparently is supposed to be equal to f of 2x plus 2. Not intuitively obvious at all, but let's go with it. Left-hand side is that. I think we better multiply that out, guys. Alright, let's do it. Yes, e to the 2x plus 2 times e to the x times e to the minus x. Now that's going to cancel, isn't it? Because that's e to the x minus x, which is e to the nothing, which is 1. So that'll just be 2. And this one, so what are we going to get? We're going to get e to the 2x plus e to the minus 2x, which is this right-hand term, plus 2. There it is, Larishy B. Now, what about that right-hand side? That's f of 2x. Yeah, I see. F of 2x is e to the 2x plus e to the minus 2x. Oh, plus 2. Oh, what a fortunate circumstance. Look at that. Of course the left-hand side equals the right-hand side. It's beautiful, isn't it? It's magnificent. That's what it is. See, because we can do it. That's why it's magnificent. Now, that's here we go with the Kaz. We've put f of x in and got a done. And then we've put g of x in and we've got a done. And then we've gone for this statement here. We've just put them equal to each other, and my goodness, we got a true. So that's lovely. So the calculator agrees that it is universally true, no matter what the value of x might be. Yeah, it's pretty beautiful. Let's do the next one now. Goodness. So f of x times g of x equals g of 2x. Come on, we'll just do the same old thing. Left-hand side is f of x times g of x. Now, what would that be? That looks very, very ugly. Oh no, it's a difference of 2 squares, isn't it? Of course it is. So it's just going to be e to the 2x minus e to the minus 2x, I would think. Dots, of course. Yes, lovely. Lovely. Let's do the right-hand side now. g of 2x, what would that be, ladies and gentlemen? Oh, it'd just be e to the 2x minus e to the minus 2x, and the left-hand side equals the right-hand side. This is fun, isn't it? My goodness, look, it's beautiful. So here's the CAS version. We're putting in, this line now. Okay, we're just saying here, because we're working with the same function, so we're saying f of x times g of x equals g of 2 of x, and we got a true. Yeah, beautiful. So that's universally true as well. Lovely. Now, what are we up to? In part 3, we're saying that f of x all squared minus g of x all squared is supposed to be equal to 4. So let's go left-hand side. What would that be? It would, of difference of 2 squared it backwards. That's rather nifty, isn't it? So let's see where that takes us. Oh, it takes us to a big mess. Okay, here's f of x. That's g of x. And here's f of x plus g of x. Now let's just clean up the mess. Oh yes, this is going to cancel with this one, isn't it? Oh, that's rather convenient. Yes, that cancels too. Oh, very nice. So what have we got now? We have to do some cancelling here, I think. You get rid of those two. There you go. So what have we got? 2e to the minus x times 2e to the plus x. Oh goodness, I see what's going to happen. It's just going to be 4, because these little gremlins cancel each other out. You remember, this is e to the x minus x, and x minus x being 0, it'll be e to the 0, which of course is, I heard you say it, 1. So we've got 4 times 1, which is 4, which is the right-hand side. My goodness, how marvellous. So then the third line there, you see I've put it in, dealing with the same functions. I've just said this minus this equals 4, and we just got a true, a universally true. So the CAS is giving us the thumbs up. Now here's another one. It looks like a multiple choice question for us, ladies and gentlemen. This time f of x equals e to the 2x for all x reals. Then we're saying that f of x squared equals, if f of x squared equals f of y, then what's y going to be equal to? A little bit of a different twist there. So I think we just better go with this and equate them as being equal and see what happens. So f of x squared is going to be e to the 2x squared, which would be e to the 4x according to the index laws. Remember, you multiply this by this, don't you? Yeah? Very good. Now, what about the right-hand side? F of y is going to be e to the 2y, isn't it? Yeah? And therefore, if we're saying that this equals this, which is the proposition they're putting to us, and then we have to work out what y must be to make that happen, then we're saying, ladies and gentlemen, that e to the 4x equals e to the 2y, aren't we? So therefore, we've got the same base, Mr. E, therefore 2y must be 4x, and you can see what's coming. Therefore, y must be 2x, and which option is that? It's A. Hooray, it's Mr. A today. And I think that's the end of our adventure into functional notation. Oh no, the last little CASI bit. So therefore, I've put it in. There it is, and got it done. And then I've gone for this statement here, and I've solved it. Look, it's a solve statement. Solve f of x all squared equals f of y, and I'm solving it for y. How cunning. And then I get y equals 2x. That's rather marvellous. Why don't you try that on your calculator? It'll give you a bit of a buzz. Okay, I think that's the end.